A couple of years ago, I made these unique round drawers out of wood, and ever since then, I've wanted to make a metal version. The only problem was I couldn't think of a good way to do it. Machining them from solid isn't ideal, as there'd be a lot of waste. Fabricating them would also be difficult and possibly not consistent enough. And because of the shape of them, there never really seemed to be an obvious way to make them. But recently I started thinking about them again, and I think casting them with aluminium is the way to go. I don't have the wooden drawers anymore. I gave those to a friend, but I really like the design and I think it's worth recreating out of metal. And now that I have a 3D printer, it's a real possibility to cast these drawers, even though there is a bit of detail here and there that may or may not work out. But that's the fun in making, trying this stuff out and see how it goes. I bought this die casting aluminium for the project, but then I remembered I had this old mower that's been rotting away outside for the last few years. So I've decided to strip it down and use the aluminium deck off that. I'll need to do a bit of prep work, but it's always more interesting using reclaimed materials. And if it doesn't work out, I still have the good stuff. I do have a fair amount of aluminium offcuts from a local machine shop, but what I've learned is it's no good for casting. It doesn't pour well. You need die casting aluminium, which is completely different stuff. With the mower deck, the fact that it's been cast before means that it should be good to cast again. I could just rely on burning the paint and the crud off when I melt it down, but it won't hurt to remove some of it first. I spent an hour or so cleaning them up, so now I'll start to chop it up into smaller pieces so they fit in the crucible. That's a fair amount and much more than what I need for this project. I will melt it down into ingots later on, but for now we'll get into making the moulds. The patterns are 3D printed on my new Bamboo Lab A2 printer. I need 18 drawers and the plan is to make 6 at a time to see how they go. There's several methods of casting. I started with plaster mould and I can tell you it didn't work out. I filmed every step of the process, but that would take 15 to 20 minutes to show it properly. I didn't think it was worth it, but I didn't want to completely omit it because it is part of the project. So here's the quick version. I printed the drawer pattern itself, then the sprue and the gate, and even a container to hold the plaster investment. After printing all the pieces, I glued them together and poured the plaster. This was the first mistake. I used casting plaster as I couldn't get any proper investment locally, and the shipping was more than what the investment cost, so I tried this instead. After brushing a thin coat onto the drawer, I glued it into the container to backfill it with a mix of plaster and sand. The thin coat was to try and preserve the details. I left them to start drying overnight, then the next morning put them in a cupboard with a dehumidifier for 5 days. I weighed them each day until they barely lost any more moisture. At this point I started to burn out the 3D printed PLA from the mould, at first in the toaster oven just to get them started, then into the burnout oven where I gradually increased the temperature. This took about 6 hours for each one. The first one burned out very cleanly, so next I poured it, and honestly I was never confident about this, but you never know. I did start to think here that maybe it had just worked, but it hadn't. It was far from complete. So the main thing I learned from the casting, or I should say from the pattern itself, was that it was far too thin, which I found out since is not what you should do with casting. And I definitely didn't get the feeding system with the sprue and the gates right. I tried one more which also failed, so that brings us up to date, and I've decided rather than make adjustments to the process and spending another 6 days waiting for the plaster to dry, I'll give sand casting a go. The first thing I need to do is dry out some sand, and that's to get it ready to make green sand. While that was drying, I melted the scrap aluminium into ingots. I bought a cheap electric furnace which worked out to be a bit slow going, but my thinking was the fact that I can set the temperature on it, it'll keep the castings consistent over the 18 drawers. Maybe I still need to get a propane furnace as well, but I did manage. I'm making the ingots now, so when I come to cast the drawers it'll be easier and most of the impurities would have been removed. The sand is dry, and by the way, it's only play sand. Just like I mentioned earlier with the plaster investment, I couldn't find any proper foundry sand locally, and again the shipping was more than what the sand cost. Anyway, play sand is already pretty fine, especially after it's been sieved. I used a regular sieve first and then a finer 80 mesh one. You can see there's some fairly sizable pieces of grit left over, and that would affect the surface finish of the casting. Now the sand is processed, we're ready to make the green sand. I'll start by making a 10 kilogram batch. I need to weigh out 9 kilograms of sand, and I'll add 1 kilogram of bentonite, which is a clay powder, and we'll bind the sand together. I'm thoroughly mixing it dry before adding any water. I'm splitting it into 2 buckets, then transferring some of it from one bucket to the other. I'm doing this a few times until I feel like it's consistent. And here's the test. If it holds together and then breaks apart cleanly, then it should be good to go. I've printed out a new pattern, but now that I'm sand casting, I won't get the textured front or the label slot. I also made the walls thicker and added a draft angle, so I'll be able to remove the pattern from the mould. I'm sanding the pattern smooth so it won't get caught in the mould and comes away easily. I'll also spray a couple of coats of paint on to make it even smoother. I've made a simple wooden flask off camera, so let's give it a go. First thing I'll use is parting powder. This stops the sand on the 2 halves of the flask sticking together when we split them to remove the pattern. After sifting sand around the pattern so it gets a consistent layer with no gaps, I'll start to fill it in with handfuls of sand to about 2/3 full. I'm just using a piece of wood to ram the sand. I've sanded the one end into a wedge shape so it not only presses the sand down but forces it sideways so the sand is compacted against the sides of the flask. That all seemed to go pretty well, but here's the moment of truth, turning it over and hopefully the sand all stays together. The second side of the flask has strips on the outside keeping it positioned, and I've marked one side so it can go back together in exactly the same place. This particular pattern doesn't stick up into this half of the mould, but most patterns probably would. Anyway, it's just the same process as before to fill this half of the flask. Next I need to cut a pouring sprue into the sand. I've marked this piece of pipe to just over the depth of one half of the flask. By the way, the 2 halves of the flask have names. This one is the cope and the bottom half is the drag. I'm also making a pouring basin which I'll pour the aluminium into rather than directly down the sprue. I believe this limits turbulent air getting into the casting. Now I can split the 2 halves and hopefully remove the pattern. Before I take it out, I'll connect the sprue to the drawer for the molten metal to reach it. This is called the gate. I can see a slight impression of the pattern in the cope, so I'll run the gate part way into the underside of the drawer. There's probably better ways of doing this, but we'll just give it a go and see what happens. That didn't go perfectly. I think I need to tap it a bit harder next time. Anyway, even though the edge broke away a bit and there's a small piece missing on one of the walls, I'll continue with it and see what happens. I just need to add a vent for any gases to escape. This can be up to the surface, but I'll try just creating a void in the sand itself. A full surface vent would use more aluminium and my furnace only has a small capacity. I set the furnace to 700 degrees C. I can only fit one ingot in at a time, so I'll let that one melt and put the other one in afterwards. Like I mentioned earlier, it is fairly slow. I left it for 15 minutes, so fingers crossed it works. I was feeling confident, but now I'm not so sure. I'm sure it could be better, but it worked. I reckon that's pretty exciting after the disappointment of the plaster molds. I much prefer this method as it only takes 15 minutes to pack the flasks and you can pour it straight away. I'll tidy it up a bit even though it is just a test. The main thing that put me off sandcasting from the start was the draft angles, but I think I can deal with those by grinding them away, and I have an idea how to do this better on the actual draws by following the curve profile. I didn't take it too far and I know it's still a bit rough, but now I'm more confident that this might happen. To make the process of casting the 18 draws more repeatable, I'm going to make a match plate. This will allow me to easily pack the flask the same every time. I'll 3D print it in a couple of parts. I'll do the main plate on the new Bamboo Lab A2 with its huge bed and the other one on the P2S. You can see here how much bigger the bed is on the A2. I mentioned in my last video how I thought 3D printers were a bit gimmicky and I was never drawn to them. I also said how wrong I was, and nothing has changed since then. I use them every day making all sorts of jigs to help the process of making the things that I make. I'm doing the same as with the pattern earlier. I'm sanding and spraying the whole thing. I did decide to do a couple of things afterwards. I thought corking the edges may help with removing the pattern. I also printed sprues and vents. And one more thing, I made a bigger flask. It would have been a bit too tight to try and fit the 2 drawers into the first one. So this is how the match plate works. It gets sandwiched in between the 2 halves of the flask. It gets packed from each side and then removed. The only problem I think I could have is the plate isn't very thick and it flexes, so while I pack the first half, I'll place a few blocks underneath. I'll try and move through this at a good rate as a lot of it is very similar to that first test. The whole sandcasting procedure seems fairly straightforward and not too difficult. The first go went very well and it should get easier all the time, especially after 18 draws. This is the main difference to the test other than the match plate itself. The sprues and vents are put in place before ramming the sand. Now to try and remove the match plate. It came away from the coat very easily. Let's see how it comes away from the drag. That's not bad. I'll just brush and blow away any loose bits and put the flask back together. I didn't cut in a pouring basin this time as I 3D printed a mould so I can make one that places on top of the flask. It only came through one vent, so I'm expecting to probably just get 1.5 draws, but you never know. And surprisingly, we did get 2 fully formed draws. They're not good enough though. The main issue is where the metal flowed from different directions, and where they met, I think it's cooled down too fast at that point and it's left a line. Anyway, I've printed a whole new plate, thicker and more rigid this time. I've also made changes to the gate design, so hopefully that helps. I've glued all of the pieces onto the board. I just need to sand them smooth and round over the end of the pins. The difference between the two plates is this only had one feeder going into each drawer, where this one now has two. It's also a lot fatter as well, so that should feed more material. I'm also going to add these bits between, and they will also feed some material into there as well. I should have mentioned that the green sand is reusable. It just needs rehydrating and it's good to go. I'm not sure if you can use this indefinitely, but let me know in the comments. In fact, I'm looking forward to reading any advice. I know there'll be improvements to make, and I'll definitely be casting again, and I'm always ready to learn. The flask was actually a bit too big, so I added another layer to the inside to reduce the volume. I decided to leave the surface vents out this time, as the test I did worked great without them. I'm pretty sure the gases also escaped through the sand itself and not entirely through just the vents. I'm finding that the process is getting easier all the time. I also printed the pouring basin mould again and made it a touch smaller. They came out pretty good, and I could definitely use these ones as they are, but they're still not perfect. They don't have the lines in the walls. They came out great, but they do have areas like that in the bottom. That wouldn't actually really matter. I could live with it, but we'll try and improve it. I'm going to add an extra piece to the match plate and thicken the bottom up just a touch. There is a fair bit of pitting around the top edge, but that's not a problem. I've left plenty of height on there, and to finish them I'll be machining the top and the bottom, and that'll clean them up. Let's see if we finally nailed it, or whether I need to make any more adjustments. One thing I've realised is I need to be more deliberate when pouring the aluminium. I think I've been too careful and pouring too slowly. This could be the reason for it cooling down too quickly and getting cold chips. Not quite there yet, and there's still a few cold chips. I'm thinking that the aluminium is cooling down by the time it gets there, so instead of pouring in here, I'm going to pour in between the two drawers and chop this off so it flows straight into the drawers. This project is a good challenge and also a good lesson too. When things don't work out in a project, we need to stop and have a good think about it and try something different. You could just keep going and do the same thing and live with the results, which would be fine, but you'd never be entirely happy with it. And the main thing, you'd be missing an opportunity to learn why it isn't working in the first place. I think staying calm, not getting too disappointed, and taking it as a challenge and a learning experience is where making becomes genuinely enjoyable. If you let yourself get frustrated, then you're definitely not having fun. Okay, let's see if this works. That was definitely more deliberate, and I'm feeling confident. They really do look fantastic. I'm super happy with that, and the finish on the fronts looks great, even though they will get ground down. So that's the tests finished and the first two drawers done. Now for the rest. I spent the next 2 days making them and having the match plate, the ingots ready to go, and with the furnace set at the exact temperature. They all came out great. I did have the mould collapse in the middle of one of them, but I was always going to make a spare one anyway, and I think that happened because I didn't quite hydrate the sand enough. There they are, they're all done, so now I can move on to something else other than the casting. I will be casting the base later on, but I'm feeling fairly confident about that now. Now I need to grind the outside so the sides are 90 degrees to the bottom. To help with that, I've 3D printed a template that the drawer will fit into. Well, actually it doesn't, so I'll scale it down a touch and print another one. It took 3 goes to get it just right, and I also decided to take the corners off in case they were interfering. They all now fit perfectly, and the template will run along a bearing on this jig that I also 3D printed. I'll line this up with the small wheel attachment on my belt grinder, then the template will run along the bearing and hopefully the drawer will follow it and give me consistent results. I've done this before with woodworking, but nothing like this where they need to be fairly precise. I've actually set the bearing slightly forward away from the belt just to see how it goes and make sure not to take too much off. When the drawers are closed, they all sit against each other, so if they're too different, they won't close properly. Also, when they get open, they need to do so with a slight clearance to the next one. I'm using a 120 grit belt, which is working very well. Even though it's not super coarse, it isn't taking long at all to get them down, and it's still leaving a decent finish. Just a quick look after the first side to check things over. It'll still need more work to get a proper finish, and also a smaller wheel to get in around the handle, but it's looking good. You know when it's done as the template engages the bearing and that starts to turn. It is getting a bit hot, so I put some gloves on. I reckon it looks great, so I'll get on and do the rest of them. Instead of the gloves, I got a container of water to cool them down. A few of them do have bad pitting where the gates enter the casting, and I think that's loose sand that's got swept in there. I could be wrong, but whatever, it's only on the gate section. Also, I saw this on the very first test casting, and it's the reason why I put the gates on the back, as they won't be seen. That's all of them to the same stage. I'll change the wheel to a smaller one and change the bearing to match. Now that they're all done, I'll machine the bottoms flat on the milling machine. It may not seem like much to the project, but there's quite a few tasks, and with the extra spare drawer, that's 19 of them to do every time. Now that the bottoms are flat, I can flip them over and mill the top edges. This is actually quite good fun and takes a bit of thought to work the X and Y wheels at the same time in all directions. It's a bit like patting your head and rubbing your tummy at the same time. They're starting to take shape and they look like an actual thing. They're all milled, including a spare. So far, none of them stand out as a glaring reject, so they're all in contention. Next, I'll start to work on getting them to a better finish, but it won't be the final finish as there's still more to do to them yet. I'll do a quick deburr around the inside of the top edge, as the middle of the drawers are going to be left with the cast finish, so they don't need any sanding. Now we can get on with drilling the pivot holes in the drawers. I know that I've already said it, but it's the same for every task. It's easy enough, but it's times 19. That's one of the reasons this project has taken as long as it has, and the other was losing a week to the plaster casting. I'm putting them onto a stainless steel rod that I'll be using for the pivots, and this is to check that they look even. They all came out pretty consistent. Next I'm going to deal with the inside of the drawers, and I want to leave the cast finish. There's a few bits here and there that didn't cast perfectly, so I'm going to fix those next. And I think that happened because I cast it upside down and the moisture got trapped underneath. If I did it again, I'd cast them the other way around, and I think they'd turn out just about perfect. I know this is a bit bodgy, but it should be a decent fix and easy to do. I could just leave them, but I reckon they're worth tidying up. Some are just about perfect and some really not so good, and then others in between. Anyway, I think what I needed to learn is how much to rehydrate the sand. I think the worst ones were the ones when I wet the sand a bit too much, and along with the fact that they were always going to trap moisture being upside down. I'm not sanding the putty at all, just wiping it clean with a rag and metha. To cover the filler and buff the whole inside, I'm trying this stuff out. This is a much better option than paint. When it's buffed, it will look like polished cast aluminium, and it's also super easy to apply. I reckon they look great, and even though it was a bit bodgy, it was totally worth doing. All of the time that I've been working on the sand-casted version of these drawers, I've been thinking about my original design with the rib fronts. I tried hammering a texture, which isn't bad, and even though I'd really enjoy the process, it's not the look I imagined. I could modify a route a bit. That would be pretty terrifying to use, especially at the start of the cut. I'll keep thinking about it, and I'll start working on the shelves. I haven't mentioned yet, but the parts do shrink a bit when casting, which you can see here. So now I need to work out the new dimensions for the shelves. To check it, I printed out a test shelf to directly try the drawers on. They need to fit quite precisely, any gaps and they'll close in too far. I think that looks good, so let's make them. The first thing is to cut down some steel sheets, which is 3mm thick. To get the project moving along, I'll cut them out on the wazer. This way I can pierce the pilot holes where the pivot holes need drilling. It wouldn't be difficult to manually make these, but the wazer will save time and the project is more about the drawers anyway. It did a great job as always, and I love the pilot holes already in place. The top one gets left without a centre hole, and the pivot holes are smaller than the ones on the other shelves as they'll need tapping. Next, I'll remove the rust. I've made a simple tapping guide from a scrap of aluminium to keep the tap upright. Some of you may remember this little tap wrench I made. It really is such a cool little tool. For the pivot rods, I'll use these stainless steel skewers. The rods will get screwed into the top shelf, and when the whole thing is assembled, I'll cut them down to length, thread the other end and secure them with nuts. That looks like it all works very well. I'll take it apart and finish the shelves. The first thing is to smooth out the tabs on the edge. The shelves will eventually get blackened, and I've had a thought about the drawers scratching them, so I've printed some liners to go between them. I can get all three on the A2L printer bed, and I thought this would show just how big it is. On the P2S, which isn't actually a small bed at all, I can't even fit two on. They would all have to be printed one at a time. They're both great printers though, they're super easy to use and they both perform flawlessly. The side with the texture straight off the print bed will be a perfect bearing surface for the drawers to slide on. I've noticed one slight issue that needs dealing with. The two drawers interfere with each other when the one is opened. It's an easy fix though, it just needs the corner rounding over a touch more. That's much better, and I've been playing around with the textured fronts and I think I have a solution for making the ribs. I did these tests and I think they look promising. I was going to make a tool to scratch the lines in, but then I remembered I had this checkering file and it works great. The only thing, it isn't quite wide enough, but I reckon that's actually worked out well. When I tried centering it on the drawer, I think it looks even better. I did it by resting the edge on a piece of steel, but for the actual drawers, I've made a block to clamp the file up against. I still need to file it a touch deeper, but that's looking great. I'm really very happy that this is being done at all. It wouldn't have been quite the same without it. To make it even easier, I'll clamp the drawer down while I cut them in. Even though I'm only using the front row of the teeth on the file and dragging it rather than pushing it like the file is designed for, it's still doing a great job. It took a good few minutes and lots of passes on each one, maybe 5 or 6 minutes, but I did have to do it in batches as my hands were starting to cramp up. I've been pushing the block down maybe harder than what I actually need to, as I've been determined to keep them neat and not let any loose dragging of the file rise up in any way and ruin one. They're all done. They will need cleaning up though, as there are some burrs left on them, but next I'm going to tackle the label recess. I've printed a jig to make the next task repeatable. It'll get attached to the rotary table underneath the milling machine where I'll mill the recess in. All of the jigs that I've 3D printed so far could be made out of plywood, and that's how I would have done it without a 3D printer, but I love being able to print a jig and get on with something else. Even though I have a spare drawer, I'm going slowly and very lightly to make sure I've set this up correctly. I'm rotating the table so far around, then moving the milling table itself in the y-axis, and then rotating the rotary table back the other way, and so on. It's a 3mm cutter and I only have one spare one, so I'm taking light cuts to hopefully not snap it. I've put 2 marks on the side of the rotary table so I can see where to stop. I'm making 4 passes and going down to 2mm in total. I was a bit nervous about this, so I'm relieved it went well. One thing I was worried about was not paying full attention and either rotating the table in the wrong direction at the start of a cut, and the same for the milling table, even though that's more natural to me because I do that more often. But it'd be easy to switch off for a second, especially when there's so many passes to do over the 19 drawers. They all went well, I didn't make any mistakes, but it did take some time. There's still one more thing to do for the labels, and that's to put an undercut slot in each end. I can't think of a good way to do this other than use a tiny dental burr and doing them all by hand. I'm putting a bit of WD-40 in there just to help lubricate the burr. That worked pretty well. You can see that they are handmade, but that's okay, and you won't see them when the labels are in place. Again, it did take a while to do all of them. The drawers are close to done. They still need finishing properly, but first I'll chamfer the edges. For the fronts, I'll wire brush them to get into the grooves, and then I'll lightly sandblast them. I'm using a brass wire brush as it's soft and should just remove the burrs without causing any damage. And the last step on the drawers, I'll use a Scotch-Brite wheel to leave a brushed finish. It's been a huge amount of work, but I'm pretty happy with that. Next I'll get on to casting the base, and of course the first thing is to 3D print a pattern. I didn't need to do this, but I wanted the edge to angle back slightly, so I did that in the pattern. I should have just machined it afterwards. Anyway, it makes it a bit tricky to remove from the mould, but I have an idea how I can do it. I'll pack the first side of the flask and then we'll see if it works. I'm not sure if this is a done thing, but I can't see why you can't dig down to the part line before packing the sand in the other half of the flask. By the way, I'm wearing gloves because when I pack the sand through the sieve for the 19 drawers, I wore my fingernail down quite badly, and that's when I started wearing the gloves. That seems to have worked well. I just need to remove the pattern and then pour it. It's not perfect, but I really am more than happy with it. I'm filing away the worst bits, and now I can get it on the lathe and machine the edge. I'll straighten it up with the tailstock as best as I can, and because the jaws are only clamped onto the tapered part of the boss underneath, I'll support it with a live centre in the tailstock. I'll quickly sand the bottom edge, and then because I now have a perfectly round edge, I can mount the base against that and machine the top section. The main spindle is made from 8mm stainless steel rod. It'll get attached to the base with an M5 thread and a nut underneath. As it is, the nut will be lower than the edge of the base, so I need to make a recess for it. My original plan for the drawer unit to rotate on the base and around the spindle was to use bearings. That's what I did on the 3D printed version, but it would require welding a collar to the shelf plates to retain the bearing. Also, between each layer of shelves there needs to be a spacer for the shelves to clamp against and leave a slight clearance for the drawers to operate properly. I think a better solution is to make bushings instead of using bearings, which will also be the spacers as well. The thickest brass rod I have is 16mm, so this acetal rod will be better suited, giving the shelves a bit more support. I decided to add one of the 3D printed discs to the top of the drawers as well as the bottom, so here I'm working out the dimensions for the spacers. The rod is just over 25mm wide, and I can get a 23mm wide spacer into the drawer unit without it interfering with the drawers. That's the 3 done on the one end. I just need to machine the other ends. Now I need to drill the centre holes bigger, and I've also changed how this whole thing fits together, and I'm now drilling through the top plate as well. Because I've changed things, the centre holes of the printed discs also need enlarging. Next I'll finish the shelves. I'll start by sanding the flats up to 180 grit. I'm not trying to get a super high polish finish. It's not a jewellery box, but something that will live in the workshop. Next I'll put them on the lathe and clean up the edges. They all cleaned up nicely, but I'll quickly sandblast them to give them an even finish. As I mentioned, they will need blackening, but next I'll make a nut for the top which will hold the drawer unit to the base. I want to make this as shallow as possible, but it will need the spindle threading into it, so I can only make it so thin. That's the reason why I've machined an undercut on the bottom to make it look a bit lighter, but it still keeps plenty of material in the centre. There isn't a huge amount of thread engagement, but for its purpose there's plenty. Now I just need to finish the top side, and to hold it I'll reuse the arbor that I used to hold the discs earlier on the lathe. I was going to mill a large slot in it like a screwdriver slot, but it's ended up that it would cut into the threaded section. It was only for aesthetics though, so anyway, let's thread the spindle. I purposely left it too long, but maybe that was a bit too much. The plan is to keep grinding them off until the nut sits close to the top with just enough clearance for the unit to rotate. It took a few goes to get it just right, so now I'll blacken and finish the shelves. I printed a container so I can use just the right amount of blackening solution to cover the plates without wasting too much. When you're finished with this stuff, you don't put it back into the bottle. You could save it, but it'll never work quite as well. I'm blackening them a second time, but this time I'm using wire wool soaked in the solution. They could definitely be to a higher finish, but I think they look perfect and they suit the drawers. Now I'll try this stuff out to finish them. I've never used it before, but we'll see how it goes. It dries very fast. I did put another coat on and it looks like it's a very durable finish. Before I start to assemble it, I do need to resize the length of the threaded section on the thin rods. I've tapped a hole in a piece of scrap the same thickness as the shelves. That's all of the parts, and I have to say it doesn't look much, especially when I think of all the work that's gone into it. Anyway, let's start to assemble it. The nut and the spindle get permanently glued together as it'll get fixed from the other end underneath the base. The pivot rods still need cutting down. I could have worked out the length, but I thought putting it together, marking it, then remove one at a time, cut it to length, thread it and put it back in would be the way to go. There's a bit of lacquer in the hole, so it's not going on easily. Also, it needs to be kept very level as it goes down. It's starting to look great, just like I imagined it would. Anyway, let's deal with the rods. It'll have an M3 nut when they're threaded, so to give it a bit extra, I'll mark it using an M5 nut, which is a bit thicker. I had a problem here though. The threads on the end of the rod had burrs on and they wouldn't go past the drawers, so I had to take the whole thing back apart. While they were in the lathe, I removed the burrs, which were actually at the start and the end of the threads. I also cleaned out the holes in the shelves by running a drill through there just to get rid of any lacquer. I have to be a bit careful how tight to do them. Too much pressure and the shelf will bend and then the drawers will get clamped and they won't be able to turn. What I do need to do is add some thread locker. It's working great, but there's one thing that I don't like, and that's the stainless steel nuts on the bottom. They stand out a bit too much. The rods are also a touch longer than they need to be. I've blackened some other nuts and washers off camera, and I'm dipping them in the lacquer. I'm thinking the lacquer on the threads will act as a thread locker. And there it is, fully assembled. There's just one last thing, it needs some labels. I'm not exactly sure what I'll be keeping in it, but it'll definitely be useful for something. The main thing is I really enjoyed the build and trying out sand casting for the first time. I'll put a link to the 3D print files for the drawers if you're interested. A big thanks to Bamboo Lab for sending me the new A2L to play with. I really have enjoyed it. It's been a lot of fun. Let me know what you think of the drawers. Thanks for watching and I'll see you on the next one.